In this video, I will be walking through a demo of Data Governor, which is a system for research data governance. So Data Governor is actually an extension tool built on top of Dataverse, which provides the core archival services. So Data Governor aims to provide a set of new features. So the first new feature is to provide encryption of data. This is so if hackers and database administrators gain unauthorized access to the data files, they will not be able to decipher the plain text information from the data files. The second feature is to allow for sharing of encryption key shares. So this is useful in situations where users without the password, as we'll explain later, or the encryption key, but possess the key shares, will be able to regenerate a key if sufficient parties with the key shares come together to regenerate the key. So this is very useful in scenarios like research data audits. The last feature would be to provide cryptographic proof of upload times. So this will be done via submitting file hashes to a external blockchain. So this is more secure. This is more cryptographically secure as compared to using the timestamps in database for proof, because these timestamps can simply be changed by anyone with access to the database. So with that being said, we can now proceed with the demo of Data Governor. The entry point for Data Governor is actually in Dataverse itself. So to do that, we can just head to a data set in Dataverse, then we can access Data Governor. So this is the home page of Data Governor. It contains the information for a single data set, and here are the files included in the data set. So if there's a icon here, it means that the file was uploaded via Data Governor itself and not via Dataverse directly. So now we can go ahead and try uploading a single file to test it out. So we can upload a sample file here. So it's a simple CSV file. Then as we mentioned, we kind of hinted previously, we'll be using a password-based key derivation function in order to generate the encryption key rather than allow the users to maintain the key itself. So this is a lot more secure and a lot easier for the user to memorize a password as compared to storing the key. So let's key in the password, and also they'll be able to have the option to generate key shares as well, as we mentioned earlier. So now you can see that key files have been downloaded, so you can go ahead and take a look. So here are the key shares. So this is the first key share, and this is the second key share. Yeah. So now let's explore a single file. So this is the file that we've just uploaded. So this is the file ID, which is the ID in Dataverse and in Data Governor as well. And then these two respectively are the hashes of the plain text file and the encrypted file. So this is the proof file. So what this is when we upload hashes to the blockchain, we actually do it through a third-party service called OriginStamp. So OriginStamp exposes HTTP APIs for us to upload hashes to, and in return to these uploads, in response to these uploads, we are given a proof file which details information such as the transaction details. So the transaction that actually added the timestamps to the blockchain, so which in our case is Ethereum. So before uploading these hashes as well, because of the high costs of interfacing with blockchain, we do an internal aggregation of 4 hashes as well. So we will aggregate the hashes of multiple files together, and this table displays the files involved in obtaining the eventual hash. So since we also do this process only once a day currently, in order to save costs, but this can also be changed in the future as well. And so since we have just uploaded this file, the aggregation process has not been completed. So as a result, there is no proof file, and we won't be able to verify the aggregation as well because there is no aggregation. So let's head to another file to explore those options. So another file we can look at is the insurance file. So so in this case there is already a proof file, and there are other files involved in the aggregation as well. So we can take a look at the proof file first. So this is the proof file. So here are the important hashes to take note of. So this hash is actually the hash that we have submitted to origin stem, and then this is the hash that origin stem submits to the blockchain. So origin stem actually does aggregation as well in the form of a Merkle tree, which is detailed here. So this snippet, XML snippet, represents the Merkle branch from our submitted hash up to the Merkle root, and the Merkle root is then actually the hash that is uploaded onto the blockchain itself. So we can take a look at the blockchain details. So this is a hash block explorer. So this is independent from origin stem, and we can look at the submitted hash here. So this is actually the submitted hash that corresponds to this hash over here. Yeah, so this is how you verify the hash, the timestamp, independently of origin stem. Yeah, so let's close it first. Then some users may want to kind of verify the aggregation process as well. So we provide a tool for convenience as well. So you can add in your file hashes and the Merkle tree snippet that I showed earlier, and then we'll calculate the actual root that is supposed to be on the blockchain. So to do this, we can copy the hashes. So instead of the Merkle tree aggregation that the origin stem does, we simply just do a simple concatenation of the plaintext hash followed by the encrypted hash. So now we can copy in the Merkle tree snippet that we are provided with, then we can aggregate it. So we can see that the internally aggregated hash, which is the hash submitted to origin stem, is this. So it starts with 7601, which actually corresponds to the hash here. Yeah, so this is the one actually submitted to origin stem. And then this is the claimed Merkle root hash, which is the Merkle root hash claimed by the snippet over here. And then this is the actual evaluated and verified Merkle root hash here, which corresponds to the claimed one. And we also check that the internally aggregated hash is also present in the Merkle tree. Yeah, so these two values prove that the aggregation process was indeed valid. Yeah, then now we can also take a look at the options that we can take for this file. So for this insurance file, we actually didn't generate the key shares, so let's generate it first. So we can key in the password. So you can see that the new key shares for this insurance file is created. Then we can go ahead and try to download the file. So the first way to download the file is via the password. So we can do it first. So let's take a look at the file to make sure that it's intact. So yeah, this is just some sample data. Then we can also download it via the key shares as well. So we just have to upload the key share files. So we can just upload it. And yeah, we got another copy of the plaintext file, which is exactly the same data. Yeah. So now we go to Dataverse to verify that the file was indeed encrypted, right? So let me just refresh it. and you can see that the very first file that we uploaded is present here, profits, and then we can actually download the insurance file. So I'm expecting the data to be binary data, so let's open it using a text editor instead. Right, yeah, so it's just random binary data. Yeah, so the attackers who have access to this file shouldn't be able to reverse engineer the plain text file that I've just showed you earlier. So yeah, that's basically all the functionality that Data Governor offers. So another small point here is that other than this verify aggregation function here, we can also go to this page to do it separately. So this kind of adds confidence that because we don't know which file or which file that you're trying to calculate for, Data Governor is more likely to not be able to provide you with malicious data meant to like mislead you or anything like that. Yeah, so this is the aggregation verification section as we've seen earlier, and then this allows you to upload any file that you want, and we'll calculate the hash of it just to make sure that the hash is actually exactly the hash of the file. So we can kind of just calculate the hash of the insurance file here. So it's UIPS6 is a prefix. Then we can go back to the file, and then we can check that it's actually the correct hashing. Yeah. So yeah, that pretty much concludes the functionality offered by Data Governor. And yeah, thank you for watching.